All right, shock test procedures. I'm going to go through this section pretty quick because we've talked a lot about this as we've been talking about the equipment. And I'm going to point you to, in here, just some high-level overviews of procedures, but I want to show you how to look at a Mil-Std and find the information on the detailed procedures and some good guidance. Okay, here's just an outline of the section of the chapter, and shock test generally done for two general reasons. One is to check the integrity of the equipment to see if it can handle some real short duration mechanical upsets that can be caused by handling mishaps, transportation, or it can be the service environment. You know, complex shocks come from, as we said, they can be from gun blasts, from pyrotechnic devices, those types of things. And of course, you can apply these to subsystems, or you can test subsystems in shock and then incorporate them in a larger system. We typically do that when we're putting a device on a larger system that will be experience shocks. We'll test it at our shock levels for our device at the subsystem level, make sure that it works, and then incorporate it at the bigger system, and that will undergo large shock tests as well. The sequence, shock testing can be done at any time. Shock is oftentimes a destructive test, and so it's done on non-production items. So, you know, you're testing out packaging or handling equipment. There's generally a good chance that your device is going to be damaged, and so it's typically done with qualification units or units not intended to be put out into the consumer market or delivered to a customer. So I've listed here a lot of test procedures that might be of benefit to you. We've talked about 810, which is listed here at the bottom. But for those of you involved in automotive, there's a Society of Automotive Engineers spec, classical shock testing of automobiles and components. And here's one by the International Standards Organization, classical shock testing of electronic assemblies for automobiles. So those may be for Gustavo and Eugenio, maybe of relevance directly to what you're doing. We've already talked about the types of shocks. There's the classical and the complex, pyrotechnique and special. And the main thing to get out of here is that if this is what you're going to see in the real world or your field test, doing these classical pulses is not a good choice for procedure. Finding something that gives a decaying harmonic is a better simulation than the classical pulses. So it's really important to understand that those classical machines, and those are the ones you'll see around most often, are the dropped impact machines, free fall machines. Those are intended for the classical pulses generally, and the impact machines are for the complex shocks. There's some common themes. In fact, this applies to, you'll see this repeated again and again in all the chapters of this book. These are just some common things you want in your test plans. Describing your device under test, the type of equipment you're using, your mounting fixtures, your facilities, instrumentation, control and data acquisition systems. It's all real common. In fact, I use the same templates for my test plans and procedures. I can use the same template for thermal testing, shock testing, vibration testing, and it gets me in that mode of thinking what will lead to success in an environmental test, and what comes, the information that helps me achieve a meaningful and valid and useful test is to make sure that I'm getting this type of information described in the plan. Again, just some things. Write, review, and get an approved detailed test plan. Write the scope. What are your objectives? What are the requirements? Get those up front. Calibrate and pre-test all your monitoring and control equipment. You know, we've talked about rehearsing with a mock-up device. In shock testing, it's critical. You never want to go into a shock test and be shock testing if it's a one-of-a-kind piece, or you've only got a few units. You don't want to be shock testing those right off the bat. The other thing is that because shock can be so detrimental, if we're making several units, we may only shock test qualification units and not shock test production units, just because we don't want to use up the lifetime of the production units. So we convince ourselves that our shock testing on our qual unit, it passes, we've got sufficient design margin that we can go ahead and put our production units out without shock testing. Shock's one of those limited things that's often accepted, that you don't shock test necessarily production units. This is more specific information that to think about and putting into your procedures and your test plans. You'll see this repeated for many of the things we've talked about, and that we will talk about this afternoon. There are, let's see, we've already talked about how in a complex shock, you're trying to simulate this, you're given an SRS, and you need to repeat your test and collect this data and have the computer generate the SRS, and you want your SRS to match the specification. And that's what this control strategy describes, and we've talked about it this morning, so I'm not going to repeat this, but this information is here for you to look back and review if you need to. Again, installation conditions of the device under test. Eugenio, you asked about how those are secured to the table. Quite often they're secured you try to secure it in the same fashion that it will be secured in its operational environment. The only difference is if you're testing out packaging, your device is inside the package and you're dropping the package. If you don't want the package to have subsequent shocks, sometimes it has to be fastened to the table. That's where the shock is being applied. And then there's one more section here I just want to mention. We've talked about this, how to calibrate a shock testing machine. You need to use what I call a dummy mass or a mass mock-up on your shock testing machine, and rehearse and get the machine dialed in to generate the acceleration plot or the SRS. Okay, in your book there's a bunch of sample shock test procedures for these types of shock tests. So a functional test where you're actually running your unit during the shock. That's not always the case. You know, if it's a packaging shock test, the unit isn't operating. But if you want to test out whether a cell phone is going to survive a shock, you may have a powered up test where it's powered up, it gets dropped, and you verify that it's still functioning. Because you can get failures induced in operating equipment that you might not otherwise incur if the unit were shut off. There's some equipment that's required to operate through a shock, and you don't want the shock to knock the unit out. So let's say you're in a military vehicle and you're driving along and it receives it runs over an explosive device, and the vehicle is designed to keep going. You don't want the electronics necessarily to get knocked out by a shock wave traveling through the chassis. So a lot of that equipment, it requires functional testing during the shock application to make sure that it stays functioning. But the rest of these we've kind of hinted at. Transit, drop, bench handling, crash hazard. These are all transportation or handling, and then these are the more complex ones.